Molecular compounds follow very simple rules when they form compounds, and because of this, it is actually fairly straightforward to predict what these compounds actually look like. And when I say what do they look like, I mean their shapes, the shapes of the molecules. For example, if you have a nitrogen molecule, N2, Lewis structures will allow you to predict that it looks like a straight line. It actually looks something like this with a triple bond. And if I had a more complicated compound, maybe NH3, Lewis structures would allow me to predict that this molecule looks like a tripod. So how do I predict what these compounds are going to look like? And there are only a few simple rules. First, all atoms form covalent bonds in order to complete the octets. Okay, all atoms, and in this case I'm talking about the nonmetals, so all the nonmetals form covalent bonds in order to complete the octets. And remember, there is one exception. All elements need 8 electrons in their valence shell, except for hydrogen and helium, which only can fit 2 electrons. We also need to remember that a covalent bond consists of a shared pair, meaning 2 electrons between 2 atoms. In a double bond, 4 electrons are shared, and in a triple bond, 6 electrons are shared. We can use these rules in order to predict the number of bonds that different elements are able to make. So first, we have hydrogen. Hydrogen has 1 valence electron and only needs 1 more valence electron to complete its shell. Therefore, it will only make 1 bond. And bonds we're going to represent with a line. So hydrogen, when it bonds, can only have 1 line coming out of it. And remember that these bonds represent 2 electrons, and it will be going to some other atom. If we move now to the rest of the nonmetals, we get to carbon. Carbon has 4 valence electrons, and therefore needs 4 more. So in order to gain 4 electrons, carbon is going to make 4 bonds, and this will usually look like carbon in the middle with 4 bonds around it. Each bond can hold 2 electrons. Now notice that carbon is a really good atom to be in the center of a molecule because it can make so many different bonds. Hydrogen, on the other hand, can never be in the middle of a molecule because it can only make 1 bond. It cannot have anything coming off in the other direction. Because silicon also is in the same group as carbon, also has 4 valence electrons, it also will commonly make 4 bonds. Now let's look at nitrogen. Nitrogen has 5 valence electrons. This means it has to make 3 bonds in order to have a complete octet. So nitrogen will commonly look like this when it's in a compound. It's also a very good element to put in the middle of a molecule because it can make 3 bonds. The same would go for phosphorus as well because it also has 5 electrons. Well, you may be looking at this nitrogen I just drew and notice that it only has 2, 4, 6 electrons around it. What about the other 2 that it needs to make 8? Well, those 2 electrons will take the form of 2 dots. We draw them as 2 dots, meaning they don't bond, and we call these electrons lone pair electrons, which are just 2 electrons that are not part of a covalent bond. So we have a lone pair of electrons on nitrogen that is not going to form a bond. Just like we started with this lone pair here, it's going to remain a lone pair once we put it in a compound. Next on the periodic table we have the oxygen group, and oxygen has 6 valence electrons. And this means that it needs 2 more electrons to complete its octet. So oxygen will make 2 bonds when it's in a compound. And therefore it'll look like this. And because it needs a total of 8, right now we have 4 electrons around it. We need 4 more. Those electrons will come in the form of 2 lone pairs. Remember, our electrons always come in pairs in our orbitals. Lastly, we have the halogens, and the halogens have 7 valence electrons. So here is fluorine, and this atom needs 1 more electron, so it's going to make 1 bond. Okay, it's going to commonly make 1 bond, so it'll look like this. And the rest of the electrons will take the form of 3 lone pairs. Now, like all rules, there are exceptions. And don't be surprised if you actually see something like this. This is a bromine with 1, 2, 3, 4, 5 covalent bonds around it, which would give it 10 electrons. This is called an expanded octet. Some atoms, because they have a 3rd energy level, can actually start bonding, making covalent bonds with their d orbitals. We're not going to discuss this in a lot of detail, but just know that some elements in the 3rd row or below in the periodic table, actually on this side because we're talking about the nonmetals, can actually have more than 8 electrons around them. And we'll see how we know when that is going to happen in the next set of videos.